cloud load balancer abuse involves exploiting misconfigurations and vulnerabilities in cloud load balancers to compromise internal systems, disrupt services, or steal data. Load balancers are designed to distribute network traffic across multiple servers, ensuring high availability and optimal performance. However, if not properly configured and secured, they can become a point of entry for malicious actors, leading to significant risks. Common misconfigurations include overly permissive rules that expose back-end virtual machine ports to the internet. Insecure network security groups, or NSGs, can allow unauthorized access to critical back-end resources. Misconfigured NAT rules exposing RDP or SSH create opportunities for lateral movement within the network. Improper Health Pro configurations can lead to all virtual machines being marked as unhealthy, causing service outages. Unsecured storage buckets, publicly accessible, can expose sensitive data to the internet, leading to data breaches. Inadequate identity and access management, or IAM, policies can grant excessive access privileges, exposing critical resources. A lack of monitoring and logging makes it difficult to detect and respond to security incidents effectively. Insecure SSL cipher suites and the use of default credentials also present significant vulnerabilities. These vulnerabilities can lead to severe consequences, including data breaches, as seen with Capital One affecting nearly 100 million people. Public IP addresses can become targets for distributed denial of service, or DDoS, attacks, disrupting service delivery. Attackers can use compromised load balancers for lateral movement, accessing other systems and data within the network. Traffic tampering, service disruptions, and data exfiltration through outbound SNAT paths are also common attack vectors. API abuse can trigger expensive back-end operations, exhausting compute and database resources. To mitigate these risks, implementing the least privilege principle is crucial, assigning minimum necessary permissions. Regularly review and audit IAM policies, and enable multi-factor authentication, or MFA, for an extra layer of protection. Secure storage buckets with the least privilege principle and enforce role-based access control, or RBAC, for load balancer configurations. Conduct regular security audits and implement network security groups, or NSGs, to control traffic to back-end resources. Enable logging and monitoring for HTTP load balancers and continuously monitor performance metrics. Use Google-managed SSL certificates, keep software up to date, and implement web application firewalls, or WAFs. WAFs protect against application layer attacks, such as SQL injection and cross-site scripting. Configure Cloud CDN to point to a backend bucket and ensure load balancer backend services are protected with edge security policies. Plan the scale of infrastructure, implement a zero-trust architecture, and utilize isolated network zones for testing. Automate configuration validation within CI/CD pipelines through infrastructure as code, or IAC. By understanding these risks and implementing robust mitigation strategies, IT professionals and cloud security engineers can significantly reduce the likelihood of cloud load balancer abuse. Protecting critical organizational assets requires continuous vigilance and adherence to best practices in cloud security.